All right. Good afternoon, everybody. It's my pleasure. It's my pleasure today to introduce Mr. Jason Bauer. Mr. Bauer is a 2002 Virginia Tech computer engineering graduate with 23 years of experience leading innovative technology teams across Microsoft and Amazon. Currently, he's serving as the director of the Amazon Web Services field support for North America. He leads an organization dedicated to helping customers successfully build, transform, and run their businesses on the cloud. Mr. Bauer began his career at Microsoft as a program manager on the .NET Framework SDK and Windows Mobile, building and leading international teams across the US, Japan, and China, focused on input technologies, including text prediction, handwriting recognition, and speech recognition. His early work on predictive text and small language models for embedded systems earned four patents and shares parallels with the large language models used by generative AI systems today. At Amazon, Bauer drove the launch of the new Kindle devices across large cross-functional organizations spanning hardware, embedded software, and web services. He transitioned to AWS in 2012, where he helped build a support organization that works directly with AWS's largest enterprise customers to design, deploy, and operate some of the world's largest and most critical workloads. So I can go on and on. So without further ado, please join me in welcoming Mr. Bauer.
Thank you very much. Thank you. It's good to be here today. It's kind of exciting to be back at VirginiaTech. I visit Blacksburg from time to time. I haven't been to this campus. It's kind of nice to see the new facility up here in Northern Virginia. The building is beautiful. You've got some amazing spaces here. I'm excited to see this facility fill up with talent over the next couple years as VirginiaTech and all of the different tech companies, Amazon, everybody else included, continues to bring talent into this area. Quick show of hands. I'm curious, who here uses AWS or has used AWS? Okay, we got a couple. Who's bought something on Amazon.com recently? All right. I'm just curious from an AI technology perspective, who uses ChatGPT or who prefers Claude? So ChatGPT, Claude. Yeah, I think the students prefer Claude a little bit more. Well, you know, I'm gonna tell a couple stories today from my career. Two of those things I just talked about, I was involved in either nearly breaking or helping to recover a couple times during my career. But what I was hoping to do, Kathleen kind of gave me a little bit of freedom to sort of talk about whatever I want, and so I thought this might be a fun opportunity to do something I haven't done before. But I wanted to share some stories that I thought might help the group here learn about what career growth really looks like in the tech industry. And I would say one of the key insights that I've learned over time is that success in your career is often about being good at what you do, being in the right place at the right time, and strapping yourself onto a rocket ship where the technology and the business is growing very rapidly. And so I'm Jason Bauer. As was mentioned, I graduated from Blacksburg as a computer engineer back in 2002. I live out in Leesburg, Virginia now. You can see here I've got my wife. I actually met my wife down in Blacksburg. So we got married shortly after school. We have two kids. My daughter is 17 now. My son's 13. My favorite thing to do when I'm not working is actually spend time on the water. We've got a lake house down at Smith Mountain Lake. So we go down there and stay from time to time and go to football games or spend the summers down there to actually spend time out on the water, going boating and doing stuff like that. I started after graduating from tech at Lockheed Martin. I worked in a windowless building out in Manassas, Virginia, as a Java developer for some Department of Defense work. And it was, let's just say I didn't really fit with the culture. So for me, it was kind of this wake-up call of I need to find something else, something that I'm excited about. And so who here remembers the BlackBerry? Anybody remember BlackBerry? Okay, we got a couple hands in the room. When I worked at Microsoft, I started on the .NET Framework SDK as a program manager, but it was really just an opportunity to get in the door of a big tech company. I had done an internship there and enjoyed the culture. I enjoyed kind of being at the forefront of technology. But once I got in the company, what I really wanted to do was go work on the smartphone technology space. Like I saw this evolution that was happening where I believed that in the future, everybody was going to have a PC in their pocket. And pretty much all of us do nowadays. But I wanted to go kind of focus on that. And so Microsoft was building at the time our Pocket PC and smartphones. We were really trying to compete with BlackBerry in the enterprise space. And I went to work as a program manager driving input technologies. So that was voice command, handwriting recognition with a stylus, and then predictive text keyboards. That was probably the most fascinating technology that I had ever worked on and was super innovative. We were doing a lot of work building these small language models. So we were taking corpuses of text, running it through a neural network, building out a language model that could predict the words that you were typing, the next word that you might be typing in a sentence, and then compressing it all down into 200 kilobytes or less, because that was all that would fit on one of these devices at the time. Excuse me. And so that was a ton of fun. I had a team in Japan and a team in China. The technology for a lot of the predictive text was something that we actually borrowed from the teams overseas in Asia, because when you think about typing Japanese or Chinese characters, you actually have to kind of select from different characters as you're typing. So it's very important to predict what the person's actually trying to type so that they can find the characters that they're looking for much faster. So we kind of took a lot of that technology and brought it over to the Latin language set in order to do English and various other language text prediction. There was just one problem. Very exciting, lots of fun, amazing technology. But then in, what was it? I think it was June 2007, Steve Jobs came on stage and introduced this, the iPhone. And the mobile phone industry changed forever. There was this big industry shift that happened at the time where we went from everybody building these devices to compete with BlackBerry, where they had these QWERTY keypads, or the Nokia type feature phones, or the Razr phones that were very popular at the time with the 12-key keypad and the T9 typing, to these large capacitive touchscreens. And now Microsoft, I will share, either didn't quite understand the momentum or the shift that was happening, or they did, the leadership was kind of in denial, but they were still very focused on the business consumer, trying to go compete with BlackBerry. And I think there was a lot of kind of speculation that the iPhone was just a iPod with a touchscreen and very consumer focused. And so the lesson that I learned during that, was really don't swim against the industry trends. The industry was changing at this time. The mobile phone manufacturers, the LGs, the Samsungs, all of the device companies wanted to go build devices that competed directly with this. And we were still building an operating system that was designed primarily for those non-touch devices or devices with a stylus. And all of the work that I was doing saw the light of day, but it didn't see the light of day until 2010. And by that point, Android had taken over that market. Google had launched their operating system. It was very popular. It solved the need that all of the mobile phone manufacturers had. And they really sort of won the operating system market for everything that wasn't iOS. And so as you've probably seen, Microsoft ended up shutting down the division. Windows Phone is no more. They bought Nokia and wasted a bunch of money. And you're probably asking, Jason, why are you telling us this depressing story? And I'm telling you this story because I want you to kind of understand what happens when you are on the wrong side of a technology shift and wave, and how to spot the next one, which I want to talk about next. So after I was working on Windows Phone for a while, a number of people left Microsoft as they kind of saw this transition, saw that things weren't going well, and left to go to Amazon to work on this product called the Kindle. And I knew several people that left. Seattle and Redmond are very close to each other. There's a lake in between, but it's about a 30-minute commute difference. But a lot of people left, and so they were telling me that Amazon was this exciting place to work, and there's a lot of great stuff happening with Kindle. But I was also kind of really worried. I was like, well, this Kindle thing, what is this? This is an e-ink e-reader. Apple is rumored at coming out with the iPad. It's probably just going to do the same thing that I just saw happened in the Windows Phone space or the mobile phone industry. The last thing I want to do is go work for another company and go through that experience all over again. But what I learned when I interviewed at Amazon was the vision. And the vision for Kindle was every book ever published in any language available in 60 seconds or less. And that was a really powerful vision for me. What that told me was that the vision was not about the device. It wasn't about go build the best e-reader on the market. It wasn't about, dominate the device market or build a better, tablet than Apple. It was about getting books to consumers. And it reminded me of the early, like, Bill Gates days of a PC on every desk, a PC in every home type vision. And so that was exciting, and that convinced me at the time to go join Amazon. And so what I learned from this was just how important mission and vision are to what you do and how you attract talent, and how you get people motivated and excited to work on a particular project. And those really large visions, those really large missions create this scale effect that bring people in and help people solve big, challenging problems and create growth opportunities for you in your own career and for others that are part of that. And so the next story I thought I'd share related to this is a story. I've never been on a private jet, but this story is about somebody who has. And so when I was working in Kindle, Jeff Bezos, in his infinite wisdom, when he started Kindle, he hired away a bunch of Apple hardware engineers, hardware designers. And he started an office in Cupertino, right next door to the Apple campus, so that people didn't have to change their commute. A brilliant move, if you ask me, but he hired some really great people away, and they started building the Kindle device. And so when I joined Amazon, I was responsible for launching new Kindle devices. So I had to work with the hardware and software teams that were based in Cupertino. I had to work with the store and service teams that were based in Seattle. A lot of the executive leadership was all based in Seattle. The whole Amazon.com and the web store and everything that you use to buy books and actually send the books over the air to the devices, all of that technology came from our development teams in Seattle. But the hardware and software was built out of Cupertino. Sorry, I'm going to trip over here. And so I would have to travel back and forth from Seattle to Cupertino from time to time. And on this one trip, when I was down there meeting with the team, I came back to my hotel after a day of meetings and was catching a shuttle to the airport. And the hotel asked if I could wait a few minutes. They said, there's somebody else that's scheduled to take the shuttle with you. And I said, okay, sure. I start kind of watching my clock to see, when are they going to show up? How much time do I have? And a couple minutes go by, and then this guy rolls up who, the person who came, his name was Steve Kessel. Now, Steve was the senior vice president for all of Kindle at Amazon, reported directly to Jeff. And I had met with Steve before. I had kind of a weekly review. I was responsible for Kindle launches. And so I'd have a weekly review where we go through kind of red, yellow, green status. What's the status of the Kindle that we're trying to launch in time for Christmas? Is the hardware on track? Is the software on track? Are the services on track? Is packaging going to be ready on time? Like we get the whole 9 yards of everything that we had to do to launch a device. And so I'd have to review that with him weekly, but I never had a chance to kind of sit with him one-on-one for 20 minutes or so on a ride to an airport before, have kind of that one-on-one discussion. And so I did what any good Amazonian would do at the time. I asked Steve, I said, tell me your story about Amazon. You're this senior vice president reporting to Bezos. How did you get started? What did you do? And so Steve proceeded to tell me his story. And Steve started at Amazon early in his career, not long after college, I don't think. He's a fairly young guy. And he started his career at Amazon as a product manager responsible for launching sporting goods on the Amazon.com website. So if you think of Amazon, it started as a bookstore. Then we started selling various different things like CDs and music and stuff like that. And then, sporting goods and everything else now that you can imagine. And Steve was responsible for sporting goods. And so he had to go negotiate and work with suppliers and get stuff into the fulfillment centers and list them in the catalogs on the website and all of the marketing and everything else. And so as Steve was doing that, he got hired in, he was working on that, and his boss got pulled by Jeff to go work on this special project called Kindle. Well, Steve kept working. He launched sporting goods, was very successful at doing that. And after he launched sporting goods, his former boss asked if he'd come work on this special project called Kindle again with Bezos and a couple others in the team. And so Steve took a risk. He went and worked with the team on the first Kindle and I think the second Kindle that they were launching and did that. And it was still pretty small at the time. Kindle was a very small business then. And so I asked Steve on that ride to the airport, I said, Steve, how did you know or when did you know that the Kindle was going to be a success? And so Steve told me about the time when, what was it? I've got the date here. I think it was in 2008 when Jeff got invited to fly to Chicago to go on the Oprah show. And so Oprah does a show, or she used to do a show every year, where she would do her favorite things episode for Christmas. And she'd highlight all her favorite things. And it just so happened in 2008, her favorite thing for the year was the Kindle, and she wanted to interview Jeff. And so Steve, Jeff, and a couple other leaders on Kindle all got on the jet and flew out to Chicago to go do the Oprah show. And they're hanging out backstage as the show airs, and they're all sitting there on their Blackberries watching the orders come in. And he said, while we were sitting there, the orders were coming in beyond our wildest dreams, and we sold out, I think, the same day. And so then the rest of the holiday season was all about getting the factories that build the Kindles to just go accelerate and build as many possible devices as they could so that they could get inventory back in and sell Kindle. And they knew they had a success on their hands. And so I tell you this story, and some people might hear this story and think, oh, wow, cool. Backstage with celebrities flying around on private jets. But what I heard when I was in that car ride to the airport with Steve was a story about an individual contributor who started at Amazon, was doing something similar to what I was doing. He was launching sporting goods. He was good at what he did. He got pulled in by his boss to go work on another project, and that project took off. It had hyper growth, it had hyper scale, and he continued to be good at what he did, and he continued to scale with the organization and scale with that growth and take on new challenges and new projects. And now he's a senior vice president, thousands of people in the organization, $1 billion plus business. that he's responsible for, and is SVP. And so that really taught me kind of that important lesson about how some of the most successful people are good at what they do, are in the right place at the right time, and really land or spot those scaling opportunities that they can attach themselves to. And that kind of leads me to my next story about AWS, because AWS was my kind of scaling and growth opportunity. I started there as an individual contributor. Now I lead a team of over 1,000 people across North America. My first experience with AWS was when we were launching the Kindle Fire. So the Kindle Fire was our first device. It was an LCD tablet. It was designed to be low cost, compete with iPad. And top secret project. Amazon's very secretive, kind of like Apple. We don't like to share or have any leaks about the technology and things that we're working on. And we were building it, and we were getting close to launch. I think it was August or maybe early September. And Jeff and the marketing team decided that they wanted to have a big launch event. They wanted to have a big event in Seattle, bring all the press in, go on stage and show off the new devices and get kind of the world excited about what Amazon was launching. And so we sent out invites to the press, the Engadgets, the Tech Crunches, the New York Times, the traditional media. I think we sent that out on a Friday, and we were doing the launch event on a Wednesday. Well, Monday morning rolls around. I'm responsible for the launch event and the coordination and everything that kind of has to happen on the Amazon website to light up the website with all the new content. As soon as Jeff goes on stage and announces the new devices. And I get a call in the morning from what turned out to be the Amazon Retail High Availability team. And they said, "What the hell are you guys doing? We heard you're launching something. Jeff sent out announcements. We see it in the press, but nobody will tell us what's going on. The Amazon.com website isn't scaled for a major launch." So that was the oh shit moment. It was like, what? Like, we've never done this before. We've never had a big like launch event. We'd always launch Kindles in sort of the middle of the night. We'd update the website. We'd send out press releases. People would see it the next day, and they kind of, gradually kind of roll into the website. Traffic would increase, but nothing crazy. And so the first question they said was, "Well, how much traffic are you expecting?" I don't know, but I do, I did what any good program manager did. I went and asked our marketing team and our product team. I said, "How much traffic are we expecting?" So they get together in a room and they come up with an estimate, and they give it to their boss, who doubles it, who gives it to their director, who doubles it, who gives it to the VP, who doubles it again. Eventually it goes all the way up to Jeff's team, and the answer comes down is scale Amazon as much as you can over the next 48 hours. Now, most of us sort of thought that Amazon.com runs on AWS. It runs on the cloud. It scales up and down automatically, right? Well, yes and no. Yes, AWS provides a lot of capabilities for software and websites and services to scale up and down automatically for traffic, but Amazon.com at that time was the single largest consumer of AWS, the single largest customer of AWS. And it could scale up, but it couldn't scale up to double the traffic. There wasn't enough free capacity in the data centers for, say, double or triple the traffic in any given day for us to scale up AWS and scale the website that much. And so, AWS depends on physical servers, physical racks, networking equipment, fiber optics. Like, if it's not installed, you're SOL. So we scaled up the site and took as much free capacity as we could for that day. And then we worked on our backup plan over the next 48 hours, which was basically, let's build a static version of the Amazon.com homepage that doesn't have all this dynamic content, doesn't require all the compute resources to show you ads and show you the suggested items based on your shopping history, and your name doesn't appear in the top right corner and stuff like that. But just have a new version that's just static of the Amazon.com homepage that's got the new Kindle marketing information on it, so that if we need to, what the plan was to shed traffic with DNS so that we would just put that static page out on S3, which is our simple storage service, and our CloudFront, which is our distributed network for content distribution. And we could handle a whole lot more traffic if we needed to. And so we built that. We got it all ready, got it ready to deploy. We had it on the go, and then we just watched traffic that day. And traffic did spike. I think we got to about 95% of what the website could handle. But luckily, we didn't have to shed any traffic over to our static pages. But it taught me, and I think others, an important lesson about how everything breaks at scale. And so even the cloud has its physical limits. And it was my first experience with AWS, and I've had to work with a lot of other really large customers, and we have to do capacity planning, and we have to do work to help them design and build and plan for their infrastructure and stuff. But it was an interesting lesson on AWS. And now if you drive out west of here and you go out to Ashburn, you will see a whole lot of facilities that look about like this. You'll see data centers everywhere. Ashburn has them all over the place. I think, well, I know that Northern Virginia has the largest collection of data centers for AWS of anywhere in the planet. And so we call it US East 1. And so if you use AWS and you log into the console and you want to deploy any sort of compute or storage or any other resource, use our AI, for example, you have to pick a region that you want to use it from. And US East 1 is often the default for people in the US. It is our biggest region. It's got the most data centers. And the way we architect or we design AWS is we use this concept of regions, which are physical locations like Northern Virginia, Ohio, Oregon, Tokyo, Sydney, Ireland, et cetera, where we have collections of data centers that we refer to as availability zones. Availability zones you can think of as one or more data centers that are all networked or connected together, but they are independent of each other in a way. They're architected in a way so that if failure happens at one, if the power goes out, if a backhoe takes out the fiber optic networking outside, if the generators don't work, or this week we had drones over in the Middle East hit data centers, there's still other data centers available to take that load. So people can build applications that are highly available, highly resilient, that span multiple availability zones or data centers so that they can build these highly reliable applications. Oh, wait a minute, went too far. And so we at AWS, we try to make this easy for companies as much as possible to build applications that span multiple availability zones that are highly available, highly reliable. We build our own services on the same kind of resiliency concept so that if a single availability zone has problems, we fail over the traffic, we shift traffic to the compute and other resources in the other zones so that it can handle that. And we do a pretty good job most of the time. Some customers leverage that and do that extensively. Some customers actually implement multi-region applications. So you'll have companies like Netflix that talk about how they do multi-region applications where they can fail over. If something's happening in US East, they can fail over to US West. Well, we do a pretty good job most of the time, but sometimes even I will say that Amazon has issues or bugs. And when US East 1 has problems, it looks a little bit like this, right? The news picks it up, global internet outage, people can't shop, people can't play their games, people can't get their groceries delivered, people can't check in for their flights. It feels like the internet's down. And well, luckily this doesn't happen very frequently, but I love my job, but when this is happening, this is probably the least fun that I have. And so I wanted to share kind of a story about October 20th of last year. So those images I think on the screen are from our October event. So we had an event in US East 1 last October where a major service that we operate across the region called DynamoDB went down. Now, DynamoDB is a NoSQL, highly scalable database that is used by AWS for various services. It's used by companies around the globe. You can think of it as a database that you can use to store whatever sort of information you want that's easy to use, highly scalable, is supposed to be very resilient, which it is 99.99% of the time. And on this particular day, we ran into an issue with Dynamo. The root cause of the issue was basically it boiled down to DNS, where DNS for the DynamoDB service got zeroed out. And anybody who knows anything about DNS, DNS is almost a single point of failure. You need DNS to map a domain name to a set of IP addresses. And the DynamoDB service operates at a scale where it's got hundreds of thousands of IP addresses, hundreds of thousands of compute instances that are running, that are load balancing, millions and billions of requests that are coming in every minute, every second to the database to store state information or store content from any sort of application or retrieve content. And we constantly have to scale up and scale down, not so much scale down, but we constantly have to add compute resources to Dynamo in the fleet of hundreds of thousands of instances that are running on Dynamo to process those requests. And sometimes servers have hardware issues and failures, and we detect those, and we remove the IP addresses, and sometimes we have to add new capacity, and so we're adding new IPs and stuff to DNS, and then DNS helps us load balance. Well, we have a process that runs that basically looks at sort of the changes that are happening across the fleet. It builds a plan for what the DNS records need to be, and then we have redundant processes that then execute that plan to make sure that those IP addresses or those DNS records get updated in the system. And it just so happened on October 20th at about 2 in the morning Eastern time that that system had a timing bug that we never hit before, where one of the redundant processes got behind, it got slowed down, it got what it thought was the latest IP record set that it needed to upload or update into DNS. And changes happened while it kind of got paused or while it got delayed. And the redundant process came in, it got a newer version of the DNS records. It updated them, and then it kicked off a cleanup process that happened at the same time as this redundant process updated the old records, and it wiped out all of those DNS records. And so when DNS is down, the whole service is unreachable. And so it took us about, I'd say, it took us a couple hours. I think I got paged at 2 in the morning and was struggling to kind of get access to systems and find out what's going on. Meanwhile, we've got our engineers across Amazon that are diving into Dynamo and trying to figure out what's going on. But it took us until, I want to say it was something like 6, 7 in the morning to get Dynamo and the IPs and the DNS records all repaired so that as customers were hitting it, they could actually like hit the servers and not just hit some zeroed out endpoint. And so it looked like things were starting to recover, things started looking good, but then we had this cascading failure of other services that depended on Dynamo. We have EC2, which is our compute service. If you want to launch a virtual server, you typically use EC2. We had database services and other various different services that all leverage Dynamo for state information, to validate requests that are coming in, to store certificates and various different things like leases that the system uses to kind of know how long it can kind of operate before it needs to update itself. And those things kind of started to expire because things had been down so long, and so they started failing. So we had this like long cascading failure across AWS that day, and restoration of all those services was super hard. We had to effectively throttle the inputs, all of the requests coming in from our services, from our customer services, in order to recover the system. It was basically like this large DDoS attack that was happening as everything had queued up and everybody was trying to retry all of their requests across all of these different services, and everything was hitting Dynamo and the various dependencies at the same time. And so restoring the service was very difficult and challenging that day. And so we fixed that. We got things back up and running. AWS is fine. We fixed the timing bug in the Dynamo DNS code and stuff. But what I wanted to share about this is that this wasn't our first event. We've had several events in my 14 years in AWS. And what I'd say, or what I'd share about them, is that many of them, and many of the bad ones, are all to some degree related to scale. And when I say that, it's not just about scale that AWS runs, the scale that our customers are running as customers in AWS, and everybody builds these applications with larger and larger numbers of resources and servers that are running in data centers, and dependencies between serverless workloads and servers and databases. And we've got various different serverless technologies like Lambda and Docker and stuff that's out there. They get more and more complex and more fragile, or more challenging, and more challenging to test, especially at scale. And so what I wanted to share was 2 ways that Amazon actually does this, or how we architect to test at that scale. Because if you think of a service like Dynamo, it's running on hundreds of thousands of servers at this massive scale, the question that I sometimes get is, well, how do you test changes, right? You're deploying code, you're adding features, you're fixing bugs. How do you test to make sure you don't break production? Especially when you're running at a scale where we don't just have spare data centers sitting around doing nothing, where we can just pick up and run a parallel version of Dynamo at production scale. And so what we actually do is, there's kind of 2 solutions that we use within AWS to solve for that problem. One is microservices. And so the best way to think about microservices is that we break down these large applications into a collection of, you can think of them almost as functions, right? These are APIs or function calls that then we design to be highly scalable, so that the function can handle tens of thousands or millions of requests per second. And you look at the different kind of capabilities of that function, depending on the network throughput that it needs, or the storage throughput, or the memory that it needs, and really designed for that kind of scalability across data centers, across availability zones. And we break a service like Dynamo into hundreds or thousands of these little microservices, these little functions that can independently scale. And that allows us to build or make changes to those individual microservices that we can then test at the scale that they're running in production, and at much larger scales than that they're running in production. So that way you can kind of validate and prove that this individual function, the inputs, the outputs, the state information, the things that it needs, the resources that it needs, can operate at 2x, 3x, 10x the scale that it's running at in production. And so that helps tremendously, and that was kind of how we initially started, and how many of our services within AWS were built and became very reliable, and allowed us to constantly deploy and update them. The other kind of concept that we use is cell-based architecture. And so you can think of cells as this collection of microservices where we can take and run sort of an instance of Dynamo and all of those microservices in an individual cell. And we can shard customer traffic and shard that across different data centers, across different availability zones within the region. And it enables us to then do blue-green type deployments and changes as well. So we can not only test those microservices all together at the size or the maximum size of a cell, but we can also then deploy changes to an individual cell. And if something goes wrong in that individual cell, well, we might be impacting 1% of traffic to the service instead of 100% of traffic. We don't actually, like if we bring down a cell, yes, it's impactful to some degree, but it's only impacting a small percentage of requests or a small percentage of customers instead of bringing down the whole service. And so that has really enabled us to scale these services to these massive sizes across AWS, give us confidence in our ability to make changes constantly, to deploy new features, new code, and test at a scale that is equivalent to production. And so this is my last slide, but it wouldn't be a talk these days without talking about AI. I haven't talked about AI for, I think, 40 minutes, but I thought I'd talk a little bit about AI and what I see happening with AI and what's my advice on AI. I get asked kind of frequently, like, Jason, what's your advice? Like, you're in the middle of this at Amazon, you see what's happening in the field, you see what's happening with customers. I strongly believe that we are still in the early phases of a new technology shift or technology revolution with AI. I see we can't scale capacity fast enough to meet demand right now at Amazon. You see, like, we're just announced $200 billion in investment in new data centers. You know, as soon as Anthropic launches a new model, like, customers are coming in and using it, and we can't scale up capacity fast enough to give to customers. And so we're scaling it just as, you know, as fast as we can get computers and data centers brought online. I see a lot of parallels in this AI transformation to my early days in the smartphone transformation and the transformation that went from IT on-prem and people building their own data centers to the cloud, right? When we were at the beginning of the smartphone transformation, companies were asking, what's the ROI for building a smartphone app, right? Like, if you were an airline, why, you know, you can print your boarding pass at home, you can buy your tickets on the computer, you can check in at the kiosk. Like, why do I need to build a smartphone app? Like, what's the return on investment for a smartphone application? It didn't always make sense initially. And I hear the same thing from customers today. Like, what's the ROI for this AI investment? And some of it's easy. Some of it you can kind of look at and see how you can change processes and reduce the need for people to do certain things. And that has kind of a tangible kind of return on investment to some degree. But other is a lot more subjective, like adding new AI capabilities and functionality to you know, various different business models or different applications that companies are running. And so it's a lot more subjective. But during that time, during that transformation, the companies that focused on sort of leaning into that new technology and innovating around it were the most successful. You see, the companies like Uber came out of the smartphone era and the smartphone transition that wouldn't have existed without smartphones, and the taxi industry never caught up. Similar challenges in the cloud transformation, right? We saw customers coming to the cloud, trying to figure out, how do I build applications on the cloud? I think the ROI was a little bit easier, but the questions we always got in the early days was security. Like, how can we prove that the cloud is as secure as our racks that are locked in a cage in our office? And it's like, well, you know, they might be more secure because do you have cameras on them? Do you know who was actually, you know, in there cleaning the other day? And so, you know, it's kind of interesting to, like, go through this. And I think we're going through it all over again right now with AI. And what I see is that the most popular AI applications, the ChatGPTs, the Claudes, the Geminis, in many ways, I feel like they're like the original iPhone. They're very limited in terms of their functionality, but they keep adding and expanding and becoming almost like a platform that's being used for all sorts of new innovative things that companies and people are doing. And so I see the future of that as not just being these little chat bots and these little, like, text boxes that are on the side of a web page or console that you use to chat with something. But I think the future is actually we're going to have these AI teammates and these, you know, resources available to us that are actually just become that force multiplier for us to just go do so much more with AI than what we've ever been able to do before. In today's world, if I want to go build something, I need to go, come up with an idea, advocate, hire a team, convince the team of, what we need to go build, get them off and building it. But being able to just go do that with AI and having kind of this teammates or sets of teammates that can go do that, I think is going to transform how a lot of companies operate, build products, and just kind of do work in the future. And so I know, especially for the students here in the room, I know the job market in tech is kind of not the best right now, I would probably say. I ran into some similar challenges myself. When I graduated in '02, we were just coming off the dot-com bust. Companies weren't hiring. I had done an internship at Microsoft, and they said, well, we don't have any positions for you. And so it took another year or two before I was able to get back there. But what I'll say is that I think the AI job market is getting started. I think the companies are figuring out what that looks like. If you look back in the early days, there weren't mobile app developers. There was no job for mobile app developers in those early days. There was no such thing as a cloud architect. There were IT architects and stuff, but there wasn't this like cloud architect in those early days. Now there's like thousands, hundreds of thousands of these roles, maybe millions across the industry that exists that have come out of these. And I truly believe that we're going to see more of these. And so my feedback to the team here is, I think my suggestion is to lean into the technology, to focus on those opportunities, those businesses, those problems that you see that are scaling, that are growing exponentially. When I joined AWS, we were growing over 100% year over year. I went quickly from being an IC to a manager of a team, to a manager of managing a larger team of managers, to now a director that's responsible across this whole organization. The growth has slowed down to some degree. It's not 100% year over year, but there are pockets out there that are growing at this crazy pace. I think I just saw a study recently about the growth in AI token usage in companies that was showing certain tech companies, their token usage was growing 100x year over year. And so when you think about that, my feedback or my thoughts to the team here, the students in the room, is go look for those opportunities and go find the technology and the businesses that are working on those really hard problems that are scaling super rapidly. Because if you do, and you get in those, and you grab a hold of that rocket ship, you'll accelerate your career. You'll work on really interesting problems that you never thought you'd ever work on before, and you'll get that opportunity to do some amazing things. And so that was my talk. I'm here for a little while. I'm happy to answer questions and take any questions from the audience about anything you got.
Thank you very much. Any questions?
Okay, a question from chat. What made Northern Virginia the data center capital of the world?
Oh, well, I think that goes back to when the government was starting the internet and started this. But between that and AOL being out in Northern Virginia, I think AOL built several data centers, and a lot of internet traffic was kind of flowing through Northern Virginia in the very early days. And so I don't know the exact answer. I just know that there has been kind of this Northern Virginia, AOL, and some of the history of the initial growth and setup of the internet really happened here in Northern Virginia. And I think that's why it's become so big. Yeah.
Yeah. I mean, just to add to that, I visited a lot of those data centers. My understanding, one of the implications was that it was outside the blast radius of
microphone.
Oh, is that it was outside the blast radius of a nuclear explosion? But from that's where they chose the Reston area. But I think the rest of it is more what you said. My question was, I liked your comment about this notion of, I liked the analogy of like mobile software development to AI chat development, and looking at AI, or at least these chatbots, whatever you want to call it, as sort of a substrate layer for development. So maybe can you tease that out a little bit? Do you have other thoughts there in terms of how would that work? You know, what kind of, do you have any applications in mind that you're thinking of? And I'm just curious. That'd be really exciting.
Well, I guess what I see is I see kind of two things, right? I see the chat applications and I see the language models that are being kind of developed underneath them. And so I think of the language models, these, foundational large language models, as being almost that equivalent to that platform. Like the iPhone was a platform to go build on, and Android was a platform to go build on. And so I see that those are becoming the platform that companies are building really interesting technology and solutions on. And then the chat interfaces, the chat GPTs or the Claude kind of desktop applications and Claude codes and stuff, I see as this kind of application that's being built on top of the language models, but where they're really taking advantage of the capabilities, adding new features and functionality. MCP, Model Context Protocol, is a way to provide or access APIs and perform functions. The agentic capabilities to go build agents and string the agents together to perform things. Even the new OpenClaw type solutions that are getting published out there, I see being built on top of this. That it's really that sort of platform concept with the models, and then the new features that the platform companies keep adding, right? The OpenAIs or the Anthropics kind of keep adding features to that model platform that then is really enabling some very interesting use cases and applications in that space, which I kind of think of very similar to sort of an iPhone as a platform that somebody then built Uber for.
Any other question? So here and then we'll go there. Okay.
What are you excited about for AI in regards to embedded devices?
What am I excited about for AI in terms of embedded devices?
Yeah.
Well, that's I don't know, to be frank. I think the thing I'm excited about with AI is this ability to democratize or enable basically like human type problem solving, and being able to assign that to technology instead of just assign that to humans. And so where you run into problems in a mobile environment or an embedded environment where you need a human in the loop to make a decision, to evaluate something, now you can use AI to go do that. And I think that really opens the door to do some very interesting things that we were never able to do before, or that never made financial sense to do before. And so I don't have the answer to that. Like if I did, I'd probably go start something. But I think that's kind of a really interesting space of just like, what are all those use cases and things that we do every day where we have to talk to a human, or where maybe we don't talk to a human, but where humans are involved in the process. And why I think everybody now is questioning, like, why do we need that? And it's not because that we're not going to need humans to do things in the future. I think humans are still going to be building, designing, deploying, operating, running these like systems at scale. But we won't need humans to go follow some process to take some piece of paper as input and go process an expense report and then go send it to somebody else to make sure that the payment gets into your bank account. Like why did we need that in the first place? Like why was that so valuable if in the first place? And so I think that's what's changing now, how that applies to mobile and what to use there. I'm not I don't have a great answer for you. Yeah.
So you mentioned that one should not build against the industry trends, but
Sorry, what was that?
you said that one should not build against the industry
Oh, yeah.
trends.
Don't fight the trend.
Yeah, but there might be a possibility, maybe a decision that you might have to make because you heard a very radical idea which could disrupt the, the tech industry or any kind of industry. I want to ask, like, how do you make a decision at that point of time to maybe go, let's do it, or this sounds very vague. It won't work in this particular because the industry is not moving towards this particular trend. How do you make a decision in that sense?
So I guess the way I think about it, based on my experience, my learnings, is not so much not to invest in like radical ideas or go focus on a new technology or something that interesting that can disrupt the industry. I think disruptive ideas are very good. And I think they're very powerful, and it's important to, I think in some ways, like those ideas, especially when they have potential to scale to enormous size, are great opportunities to go take a risk on and to go jump in and get involved and do that sort of early, especially early in your career. I think it gives you lots of opportunity to grow, experiment, and it's okay to fail. Right? I think that's the other thing. Like it's okay to learn and grow from that. But my feedback is more around in terms of fighting the trends. It's you have to kind of be careful if you see a trend and your company or the group that you're working on is kind of going in the opposite direction or isn't kind of following that trend or where you see the market and customers actually going. If the customers are going to the iPhone and see that as the future, and you're working on something that's targeted for the old feature phones that might be the biggest market share. Let's be honest. Like at the time, like that was the biggest market share. Like if you're just focused on market share, you can build a business plan that says we can go build this thing and sell it to companies that run on, and consumers that use feature phones, and it's, hundreds of millions of customers, and it's way bigger than the iPhone market share. But you're fighting the trend, right? The trend is that this is the thing that everybody may have in the future. And so if you do that, you run that risk of your business model fighting that trend, and actually by the time you get to deploy and launch and go to market, that the market isn't there anymore for you. So that's my feedback on that.
Kind of like the BlackBerry.
Yes. Yeah.
Okay, I have two questions from Zoom. First one, at what stage in your career did you shift from focusing on building features to thinking in terms of systems and scale?
Yeah. I would say that kind of happened in two phases for me. So when I worked at Microsoft, I was very much on the product feature development side of things. And that was, again, it was very fun, very exciting. When I moved to Amazon, I was more responsible at the beginning in Kindle. I was more responsible for project management, program management, responsible for coordinating all of these different technology teams, business teams, and other groups. And that was exciting and fun, but I wasn't getting my hands dirty. I wasn't actually building stuff anymore, which also kind of, as an engineer, I always enjoyed building stuff. And so then I went to work for AWS initially as a technical account manager. And I was building some stuff. I was building samples and solutions for customers to show them what was capable of on AWS and in the cloud. But I was doing more work to just kind of help companies and help customers kind of do that, right? I was showing them how to do it and then helping their engineering teams do it, which was actually super gratifying. Like it was a lot of fun. And part of the reason it was a lot of fun was because it was like super fast. Like you'd come up with these ideas, you'd show it to a company, and you'd see them like either adopt it and start using it or not use it. But we typically see them start using some of these cloud services and then deploy something, and you could very quickly, in a period of a few months, see them be successful at something, which was a lot shorter time frame than say like 2 years launching a new hardware device. When I became a leader, a manager of a team, and then a manager of a large organization, is when I'd say the switch flipped to focusing much more on optimizing kind of business processes. At Amazon, we refer to it as mechanisms. And that was kind of one of the aha moments at Amazon was when I learned how to build mechanisms, not processes. And so at Amazon, we talk about mechanisms as being this complete process where you have technology like a tool, a process that people follow, an inspection mechanism that's used to inspect to make sure you're getting the right set of outputs. But it's kind of, in a way, it's kind of taking almost like a software development lifecycle or software engineering kind of skill set to human processes and figuring out how do I scale something so that we can take reliable inputs and get reliable outputs, and we can do that at massive scale across, thousands of people, for example. And that was really fascinating for me because it's very different trying to get people to do things than it is to just write some code to go take some files and process some inputs and generate some output.
Okay, one more question. How do you evaluate whether you're in the right place for long-term growth, especially when the industry direction isn't yet clear?
So my advice to the students here and people early in your career is ask questions and dive in with the company or the team that you're interested in working for to understand the business and in particular, the growth rates. How fast are they growing? How fast is the business growing? How fast is the technology growing? How fast are they, how fast is their infrastructure that they're using for, AWS or, whatever the technology is that you're interested in? Like, is it growing 10% year over year? Is it growing 20%? Is it growing 50%? Is it growing 100%? Is it, are they growing 10x, right? Like they're getting, 10x the customers they had last year. The applications are supporting 10x the number of users that they had before. Like if you find yourself in a place where they are growing like 10x, you're going to find yourself in a place where you get opportunities to solve all sorts of really interesting problems, both on the technology side as well as on the business side. Because when you're growing at 10x, it doesn't take very long for you to outgrow your technology, for you to outgrow your people, for you to outgrow the processes that you have in place. Like when you're this small team of, 4, 5, 10 people, it's easy to kind of all coordinate and communicate and help each other out and solve problems. But as the business grows, as the technology grows and scales, you end up having to bring in a lot more people. You have to solve these harder technology problems. And that leads to like all sorts of opportunities. So that's my advice, is to really focus on that. Ask those hard questions. Find out how fast the technology and the businesses and the teams growing that you're potentially working for, because that'll tell you a whole lot about kind of the opportunities that are going to be available to you for you to grow.
Thank you, Jason. Thank you very much. This is an inspiring talk, and thank you very much. We really appreciate it. Thank you.